Hello everyone. We are Group 1, and in this video, we're going to discuss our learnings from the video by Hegamo about pneumatics and actuators using the FESTO FluidSIM software. So let's introduce ourselves first. I'm Aiman, and with me today are Arvin, Daniel, and Satesh. So we will talk about two major types of actuators: single acting cylinders and double acting cylinders, and show how they were applied in simulation and in real life.
Right, first of all, what is pneumatics? Pneumatics is a branch of engineering that uses compressed air to create motion or force. It's widely used in industrial automation because it's clean, fast, and relatively inexpensive. The video we watched explains how actuators move when the air is controlled using valves and how we can simulate this by using FESTO FluidSIM software.
Okay, I will start with a single acting cylinder. So single acting cylinder only uses air to move in one direction, usually upward. So what happen in the single acting cylinder is essentially have a spring inside pushes it back when the air is released. If you refer to the video, the single acting cylinder is controlled by three two-way valve, which means the valve itself have three ports and two positions. So one port for input, one for output to the cylinder, and one for exhaust. In FluidSIM, we can simulate this by pressing a push button to activate the valve, sending air to the piston. And once we let go, the spring automatically retracts it. So I would say the single acting cylinder is actually simple, quite efficient, and actually commonly used in stamping, clamping, or ejection system.
Okay, now the double acting cylinder. The double acting cylinder is more advanced. It uses compressed air for both extending and retracting the piston. This means no spring is needed. Without the spring, we use 5 two-way valves with 5 ports and 2 positions. Port A sends air to extend the piston, while the port B retracts it by reversing the flow. In our FluidSIM test, we use a lever switch to alternate between positions. This type of actuator is usually will be used among robot arms, machine tools, or automated doors, where there is a two-way motion and control are required.
Now let's talk briefly about real-life uses. Arvin, what's an example of a single acting application?
Sorry, Arvin,
Sorry, Arvin,
the
your voice.
microphone.
Oh, right, sure. One example is door closers. So basically, when you push a door open, it uses air to extend, and the spring automatically closes it, meaning to say that when you give compressed air, the cylinder pushes forward and it will only retract once the air pushed forward is not being supplied anymore.
I would like to add another examples. If I'm not mistaken, ejector pins in plastic molding machine also use single acting cylinder. They use single acting cylinder to push out the molded part.
Okay, for the double acting ones, I have seen them in automated conveyor stops, which the air extends the piston to stop a product and retracts it to let it move.
Okay, so great example. So choosing the right actuators depends on the function, force needed, and space available. Okay, pass to Arvin.
Right. So basically, when we were looking at this video, we are supposed to enact how a um, single acting cylinders and double acting cylinders work. So in which we have already simulated one of the drawings here. Right. So this is a difference between a single acting cylinder and a double acting cylinder. So as you can see here, this is the single acting cylinder, and this is a double acting cylinder. So what differs a single acting and a double acting? So a single acting has only one inlet, where else for double acting we have two inlets. So how does this work? So let's say instead of having this, we move the connection and we provide an air supply, or in this case, compressed air supply, and we connect it to the inlet. So once we simulate open connection due to this not being connected, anyways, yeah. So as you can see here, once the air compressor supplies air, the cylinder is being pushed out or shoved out. This also happens when we use double acting cylinder. When we give an air compressor, it pushes out the cylinder, but instead of disconnecting this air supply and the spring retract the cylinder back inside, we have another inlet in which once we release the air pushing it, we can also retract the cylinder. So this is the motion when it go out, and this is the motion when the cylinder is being retracted in. So how does this cylinder being retracted in a slower manner? We have this what we call as N valve. So to be specific, this valve is called this valve is called okay. So this valve is called shuttle valve. So this shuttle valve has a check valve, and also here we can change whereby the standard nominal flow, meaning that the air being let out is in this volume, and also we can adjust in the way of opening level being in percentage. So the lower the amount, the slower the air will be retracted back. So let's say 100%, we push, it will go out, and when we push back, it will retract inside in a faster manner. So once we adjust here, let's say for just now 5%, when we push out, when we give compressed air, it push out normally. Then when we push to let the inlet air out, it will retract back in a slower manner, in which you can see here, the compressed air pushes here, retracts back, and then release air out. So this is what we call as a shuttle valve, and then here this is what we call as one-way flow, in which the compressed air only goes one way, and then when the cylinder is being retracted, the valve will remain at its position. So for example here, if we were to connect this, right, so when we press play and we give compressed air pushed out, once we close this, you can see the check valve release, and then the air is being released and the spring retracted the cylinder back. So if this check valve is not there, the air will continuously being supplied, where it will have no intention or no chance to let the air being let out. Instead of having this check valve, it will able to be let out via this valve. So more or less, we can see the operation between a single acting cylinder and a double acting cylinder. So single acting cylinder having one inlet, double acting cylinder having two inlets. So when compressed air is being supplied, both will protrude or will act out, but instead of one being manually retract when air supply is not given, the double acting cylinder will have another inlet whereby we give the supply in and the cylinder will be retracting back. So yeah, so that's more or less on our activity or the simulation that we do based on the video today. Back to you, Aiman.
Okay, quick question to the group. Why do you think the single acting cylinder is considered more energy efficient?
Because it uses air for one direction. The spring handles the return stroke, which saves air and energy.
In my opinion, single acting cylinder has its limitation, which is it only uses uh, air for one direction. And I think for heavy duty or fast operation, double acting is better.
I agree that. So each type has pros and their cons depending on the applications.
Okay, to wrap up, we have discussed the difference between single acting and double acting cylinders, their components, real world uses, and how to simulate them using FluidSIM. So this activity really help us to understand the basic of pneumatics and how actuators are used in industry. So thank you for watching our discussion. That's all. Bye. Thank you.